Hello and welcome back. We're going to look at some parts concentrations here. And the thing about these concentrations, they're always a ratio of the part of the solution that is solute to the whole solution itself. And sometimes we work with masses, in which case we're looking at grams to grams or kilograms to kilograms. And sometimes we're working with volumes, in which case we're typically looking at milliliters of one to milliliters of the other. And on occasion we will mix them up, and we'll talk about that later. So let's go ahead and look at the percent by mass first of all. So the percent by mass, sometimes the percent by weight, is defined as the mass of the solute over the mass of the whole solution. And a percent converts that fraction into a percentage by a multiplication factor. And of course, we know that there's 100% in a whole. So for example, if we had something like 1.35 grams of salt of sodium chloride dissolved in a solution with a total mass of 151 grams, then we could calculate the percent by mass of sodium chloride. So sometimes we write that as percent weight, and that would be the mass of the part compared to the mass of the whole. And to get to a percentage, we multiply by 100. So I get 0.894%. Okay. Occasionally that's written as WW to kind of indicate we've got a weight over a weight here, or a mass over a mass. Sometimes people write M over M. So it turns out we can actually be given a percentage and use it as a conversion factor as well. So let's turn the slide and try that one out. So we can use the weight percent as a conversion factor. For instance, if we had a solution that was 15 weight percent sodium chloride. So we're going to go ahead and write NaCl AQ. Remember, AQ means that the solvent is water. What that means is that 15 out of 100 is sodium chloride. So we got 15 grams of sodium chloride for every 100 grams of, not of water, but of the whole solution. Remember, we're looking at the whole solution here. And we can use that as a conversion factor. So for example, if we wanted to know, say, what mass of solution do we need to contain, 75 grams of sodium chloride, then we can take our 75 grams of sodium chloride and multiply by that as a conversion factor. So, of course, we need to put the grams of sodium chloride on the bottom to cancel out. And the 100 there is exact because there's exactly 100 in the whole. And we can go ahead and we can figure that out. And on my calculator, clickety-clack, if I type that in, 75 times by 100 over 15, I get 500. So probably two significant figures. So 500 grams of solution. Or if we wanted to, we could write 5.0 times 10 to the 2 grams of solution. So that's kind of neat. So we can write percentages as factors, and we just write the percent, as the number over 100. And if it's a weight percent, then it would be grams over grams like so. For really low concentrations, it turns out percentages are going to be really inconvenient. So for example, maybe we've got some benzene and we've got 0.0000035 grams of benzene. And benzene's a carcinogen, and it's in a solution of total mass of, say, 52 grams. So we can go ahead and we can calculate the percent of that. So the percent by weight is going to be the weight of benzene, so 0.000035, okay, over the weight of the solution, so 52. And remember, we convert to a percentage by multiplying that by 100. And if we go ahead and we type that in, we get an exceptionally small percentage, which I make to be 0.000067%. And you look at that and you're like, oh my gosh, right, that's way too small. So instead of that, we're going to use parts per million and parts per billion. So it turns out a part per million is basically the same thing. We use the mass of the solute over the mass of the whole thing, the solution. And whereas a percentage was parts per 100, parts per million, right, is basically we multiply by a million. So a million is 1 times 10 to the 6. So essentially we do exactly the same calculation as above, but instead we multiply by a million. So it would be 0.000035 grams divided by 52 grams. And then we multiply by a million, so multiply by 10 to the 6. So you can see that's the only thing that's changing there. And all of a sudden, right, that gets a lot more exciting here. So that is, well, let me see, 0.8 0.067 parts per million. And you might say, well, that's still kind of small, right? So maybe we can go to part per billion. And part per billion, sorry, I changed the color there, is basically the mass of the solute over the mass of the solution. But instead of being a percentage or a part per million, it's part per billion. So that's multiplied by a billion. A billion is 1 with 9 zeros after it, at least the US billion is. And so if we do the same calculation, but we multiply by a factor of a billion, we essentially just shift the decimal point over 3. So now it is 67 parts per billion. So that's a very small concentration, but it turns out chemists are pretty smart people. We can measure those concentrations fairly easily.